Oh, today had a couple of technical difficulties getting our live stream launched here, but we're really glad that you're able to join us. So today we're going to be doing a webinar talking about 12-volt battery technology. Now, what you're probably thinking is, oh, 12-volt batteries, they're not that complicated. There's not that much to them. Actually, there's quite a bit to them. On a lot of modern vehicles now, we have quite a bit more going on with the 12-volt electrical system than there has been in the past. Today, we are going to focus specifically on batteries themselves. Some of the stuff we've done in the past, we've talked about a few different other aspects, such as charging system, starting systems, and we can go into that quite a bit deeper in a number of different situations, potentially in future webinars. But today we're going to focus on battery technology because there are a lot of very specific things you need to understand, whether you're a vehicle owner, a DIY repair enthusiast, or a professional automotive technician. There is far more to the conversation surrounding batteries than there is traditionally or conventionally perceived. So, to that effect, we're going to go ahead and walk through a variety of information here. If we have any time left towards the end of the webinar, we will try to do a little bit of live demonstration. If we don't have enough time to do that today, then perhaps we can do that on a future webinar. But again, we're going to try to cover this part first, since this is the most crucial element of what we're trying to get across. All right, so what we're going to try to talk about today specifically is we are going to talk about different types of automotive batteries. Conventionally, most of us have been taught that there are not that many types of 12-volt batteries. That is actually false. 12-volt batteries, there are a number of different types. We're going to go over the common types that you are going to encounter in the real world, whether that's in your own vehicle or in vehicles that you're servicing at a shop. We're going to cover different types. Now, we're not going to have enough time to go into a great deal of depth on any of this stuff since we only have about an hour, but we are going to try and cover quite a bit, even in that short amount of time. So I'm going to just try to make sure that I don't have any questions coming through here. And looks like everything's good currently. So we're going to talk about the different types of batteries that we're going to encounter out in the field. We're also going to talk about how we identify vehicles that will require a relearn or battery coding or a data erasure, like a adaptation. There are a couple of different strategies we can use for this, and we'll go over some different examples. We will also, if time allows, go into some service information to show you whether or not the vehicle manufacturer does in fact tell you if that procedure is required. Because sometimes they don't tell you in the service information even when it is required. But we will give you a tip on how you can identify those vehicles, even if it is not called out specifically in service information. We're also going to talk about your Topdon scan tool and the various parts of the conversation that it can help you with related to battery service. We're going to talk about the Tornado 90,000 and T120A. If you don't understand some of the settings on there, it is really important to be aware of this. We're also going to talk about some of the other testing tools like the BT600, the BT600 Plus, as well as the BT Mobile Pro S. What we find is when we are using battery testers on batteries, sometimes the battery tester may not provide a definitive answer on the health of the battery. And we'll talk about some different strategies and tips that you can use specifically to get better accuracy and better clarity if you're trying to sort out whether or not a battery is in fact faulty. So that being said, we're also going to talk about the role of a thermal imager. The thermal imager will be a crucial step in your overall service process working with 12-volt batteries, and we'll explain how you're going to use it and why you're going to use it. We're also going to lay out a fairly standardized procedure for analyzing or testing batteries so that you can use this on the regular when you are attempting to diagnose battery concerns. Whoop, gotta go back. So just want to share the disclaimer with you. Any information we share in this webinar is provided as a courtesy in an attempt to help you work on vehicles more effectively. However, we always want to make it crystal clear that nothing is guaranteed with the content in this webinar. We do our best to make sure we are using vetted scientific information in order to write these trainings and such, but we are not assuming any liability for the content in this. This is meant as a courtesy, not as the law or a guaranteed 100% accurate type of scenario. So just wanted to make sure that that was crystal clear before we go ahead and proceed. So now we're going to talk about automotive batteries. And again, we're going to kind of talk through all of the different technologies that there are so that you can have kind of an understanding. We're going to spend most of our time on 3 different types of batteries. There is a 4th type that we'll briefly touch on, but we're not going to get into much depth on that because it is limited in overall occurrence today. And if you desire, we can certainly do a webinar more on that later in a future time. So these are the different types of batteries you're probably going to run across out in the field or in a vehicle when you purchase it. The most commonly known is lead acid. And again, we're going to talk about some of the characteristics with each of these, what separates or differentiates them, what are the different things you need to be aware of, and how are they being serviced differently. So lead acid is the conventional that most people are familiar with, and that's what we're going to find in the vast majority of kind of lower line electrical or simpler vehicles, and of course, older vehicles. So for a long time, lead acid was pretty much the only battery you would see. Now, there is a much more diverse list of different possible batteries you will find installed in vehicles. We can see EFB or enhanced flooded batteries. We can also see AGM or absorbed glass mat batteries. AGM have been around for a fair period of time. They were oftentimes pursued as like an enthusiast upgrade, and some vehicles with extraneous or additional electronics would use an absorbed glass mat battery as opposed to just a lead acid. There is a lot more commonality in vehicles now that will have EFB and AGM than there were in years past. So again, these are types of batteries you need to be aware of because they are not necessarily going to be serviced the same way, and they do have different requirements. Lithium is another type that you're not going to run into necessarily super commonly, but you do need to know that it is out there just so when you're identifying the battery in the vehicle you're working on, being aware that this may be a battery type that you'll run across. So now we're going to do just a general comparison of battery types so you can kind of get an idea of what is the difference between all of these technologies and how is that going to affect the overall characteristics, the performance, and also in some cases we'll talk about the cost as well. So this is a little comparison chart I put together using a bunch of different resources, and we're going to kind of talk through it. So in the table here, we have the aspect which is basically the chemistry. So that's going to be lead acid on the top left, enhanced flooded in the center, and absorbed glass mat on the top right. So we need to understand that these are different from a chemistry perspective. They are also different as far as maintenance possibly that you can actually perform on the batteries, as well as maintenance required, and in terms of their performance characteristics, as well as how we service them. So as we look through the chart here, we're going to go over the parts that are really crucial to understand. When we are dealing with lead acid batteries, these batteries sometimes can actually be opened and distilled water can actually be added to the battery when they lose electrolyte over time. So liquid electrolyte can essentially evaporate, and it is possible that when that happens, you can add distilled water to the battery. Now, a lot of modern lead acid batteries are now sealed, and they don't allow you to do this anymore. But some lead acid batteries will allow you to add distilled water if they are low when you look at them. Now, many of them will have an indicator on them and have some kind of a call out that says, hey, if the indicator is this color or this color, you need to add electrolyte or water, essentially. So These are also spillable batteries, so please be careful since they do have a physical liquid inside them. Now, as we move over on the electrolyte conversation with EFB, EFB still have liquid electrolyte in them, but it is important to understand that they don't lose water over time the same way that liquid electrolyte, regular conventional lead acid does. They are also oftentimes sealed and cannot have water actually added in most cases, at least in the ones that I've encountered out in the field. And then we have AGM, which are fully sealed batteries. These are not going to have a liquid electrolyte in them, and they are not something that you can physically service internally. So, just important to understand those differences right out of the gate. Again, the EFBs do have liquid in them, but are oftentimes not actually serviceable. So, some of the other things we want to be aware of with respect to how we service these batteries is how these batteries are going to charge, which we're going to talk more about in depth in a little bit here. We also want to understand that their behavior in terms of their performance are different. So the lead acid battery is generally not going to stand up or handle repeated start stops or a lot of short trips. If you have this in a vehicle that is sitting for long periods of time or does a lot of short trip driving, it's going to tend to not hold up very well. So again, lead acid batteries can really have issues if that's the type of environment they're being exposed to. So if, for instance, we are dealing with a vehicle and the customer does a lot of short trip driving and the vehicle came with a lead acid battery, considering changing that battery type to AGM might be something worth discussing. And we'll talk more about some other considerations with respect to changing batteries in just a little bit here. Now, the other thing we want to understand is how much these batteries can handle being deeply discharged. So we need to look at, if we look at the depth of discharge part of the chart here. So the AGM is the most capable of being discharged into deep, basically low battery voltage. So the deepest state of discharge is going to affect the battery's longevity and performance. AGM can handle this better, and therefore, if the customer leaves the headlights on and the car goes low battery voltage and the battery gets into a state of deep discharge, that could potentially wreck a lead acid battery, depending on the age of the battery and how much time it's been in service and how much low state of charge it's experienced. In an AGM, there's a good chance it may be recoverable much easier simply because they have greater overall tolerance for this. The EFB is kind of somewhere in between. These are going to be tolerant of operating in a low voltage state or low state of charge in a way that a conventional lead acid is not. So the EFBs, you will find when you're servicing vehicles, a lot of the time on an EFB, you may hook up your battery tester and the state of charge of the battery may appear very low. I've seen many EFB batteries that are at 12 volts flat with no faults in the vehicle and no performance concerns of any kind because the vehicle charging management system is allowed to and programmed to maintain these batteries at a lower state of charge and a lower baseline voltage. So there are some kind of strange things you'll see when you encounter the EFB batteries specifically. They are not like regular lead acid or AGM as far as the voltage level that they are consistently held at by many vehicle charging systems. So again, that's very important to understand simply because that will affect your testing judgment. And we'll talk more about that as we go a little deeper here. Some of the other things we want to understand is start-stop system compatibility. So a conventional lead acid here down on the bottom left is not acceptable for a vehicle with start-stop system unless that vehicle has a secondary battery that is used for the start-stop system, or a capacitor, as some vehicles will use a capacitor to restart the engine as opposed to a regular cranking battery. EFB batteries are used for start-stop vehicles in a large number of situations as a cost savings measure. And then when we are dealing with higher line electrical vehicles or vehicles with start-stop systems where the manufacturer is not attempting to save money, then an AGM is frequently what you will see used. So there are a number of different considerations here, and obviously you can see there's quite a bit of information in this table, some of which is not necessarily going to be crucial to your day-to-day operations, but it is important to have a general understanding of this information. So one of the other things we have to understand as we realize there's a differentiation in chemistry as well as use case for lead acid, EFB, as well as, excuse me, AGM, is we need to understand here that desulfation is something that has to be performed on both lead acid batteries, which are conventional, and EFB or enhanced flooded batteries. It's important to understand that how this is carried out is physically going to be different. So we're going to talk a little bit about that. Before we undergo any desulfation of any kind, it's very important to understand when we do desulfation on a battery, it is very possible that there are going to be toxic gases vented from the battery. If toxic gases are being vented from the battery, that needs to be performed in a well-ventilated area, not in a sealed closet, not in an area where there's poor ventilation. These gases can be hazardous to your health, and they can definitely be a risk. So you need to make sure that if you're going to do desulfation procedures, it's in a well-ventilated area. So what we have to understand here about a conventional lead acid as well as an EFB is, for lack of a better term, the electrolyte can lose its mix, if you will. The chemical mixing inside the battery essentially starts to separate out in a way that causes the battery to perform worse and worse over time. Now, on a conventional lead acid battery, we have frequently been used to seeing chargers have an automatic repair procedure. So your Topdon Tornado 90,000 and 120A, both of those chargers have a repair function on them that is designed specifically for lead acid conventional batteries. So that charging cycle can be applied on a conventional lead acid battery, and it will perform desulfation, it will recharge the battery, and it will attempt to recover the battery to a good state of health. So if you have a customer who's been driving around short trips and the lead acid battery is seeming like it's not performing, the car's maybe having some problems starting, if you have ruled everything else out and you believe the battery may be the problem, using the repair procedure or repair mode on your Tornado 90,000 or 120 can potentially bring that lead acid conventional battery back to life. If, however, we have an EFB or enhanced flooded battery, we have to understand that this repair procedure is going to be different. On an EFB battery, we're going to use the standard lead acid charging mode first. Charge the battery up until it's at a full state of charge. Once it's fully charged, then we're going to set it to supply mode on the 120A or the 90,000. And when we set it to supply mode, we want to limit the current to something reasonable, such as, let's say, 20 amps. And we want to set that stable voltage to 14 or 14 and a half, somewhere in that range. Then what we're going to do is we're going to make sure this battery is in a well-ventilated area, and we're going to let that battery charger sit on the battery at a stable voltage, and it's going to push current into the battery up to whatever the limit of the battery will accept for as long as the battery will continue to accept a charge. Now, as it's doing this, you're going to watch and monitor and check on the charger to watch what the amount of current flowing into the battery is. And the 120A as well as the 90,000 will show you how much current is flowing into the battery. What we're going to watch for is when that current flowing into the battery drops down to roughly 1.5 amps, somewhere in the very low range. Now the battery should be fully desulfated and the electrolyte mixture should be restored. This can take up to 5 hours on EFB batteries, so you want to make sure that you're checking on it regularly. You also want to make sure that the battery is not getting super hot. So again, making sure that you're checking on it. You might even want to set up your Topdon thermal imager for monitoring purposes and aim it at the battery. And if the battery temperature starts to climb excessively high, please stop the charging cycle immediately. We do not want to have a scary incident there. But understanding that desulfation charging for the EFB, or enhanced flooded battery, is not carried out the same way as the conventional lead acid. We do need to understand that is important, and it needs to be carried out this specific way, not using the normal repair mode on your charger. So now we're going to talk about lithium batteries. So when we're talking about lithium batteries, these batteries are starting to show up in some vehicle applications. Predominantly, you're going to see them in hybrid vehicles. You might also see them in battery electrical vehicles. These cannot be charged using a normal standard battery charger. You need to use a battery charger that specifically labels lithium compatibility. On many chargers, including the Topdon, you will see it labeled as LiFePO, or lithium iron polymer. LiFe, like life, PO, or LiFePO4 in some cases. So in many situations, you're going to see it labeled like that on the charger. That is the mode that is specifically designed for lithium batteries. Again, make sure if you're charging a lithium battery, you're going to do it specifically using the lithium battery charging mode, not any other charging mode. Again, these batteries are not going to be charged using conventional means or conventional charging profiles. So now let's talk about when we're going to do any battery service. We have a basic understanding. Here are the different types of batteries we're watching out for. Here are some of the characteristic differences between them. Now we have to have an understanding of what are we going to do when we're in the bay. Once we identify what kind of battery the vehicle has, we need to know where we're going to go from there. So the first thing we want to understand is we want to pre-scan the vehicle. Before we do anything else, testing batteries, charging batteries, whatever it might be, pre-scan the vehicle, save that information. Doesn't matter which Topdon tool you're using, as long as it can do all system scanning, just make sure you're pre-scanning the vehicle and you're saving this information. Now you ask, how is this relevant to battery service? Many times on modern vehicles now, when you get a low battery voltage incident due to a battery in a low state of charge, or due to a battery that is perhaps starting to fail, you may get fault codes in various modules complaining about low battery voltage. You may also get communication faults if the battery voltage falls too low, and you may see other clues that signify there is a battery problem with the vehicle. So again, pre-scanning the vehicle is a good policy here. I would also recommend you take a picture of the dash lights on the vehicle before you do anything else after you do the pre-scan. So perhaps you're going to be starting the vehicle. I would generally not start the vehicle right away first. I would make sure you've collected your pre-scan. When you go to do the starting of the vehicle, I would definitely capture a picture of whatever lights are on the dash before any service on the vehicle is performed. This is good for baselining the vehicle and having a clear picture of the state of health, again, which could tie into the battery state of health and also help explain anomalous electrical behavior of the vehicle. After we've done the pre-scan, we also want to do a visual inspection. So we want to physically look at the battery and see if there's any corrosion on the terminals, any corrosion on the cable ends, any fraying of the cable ends, anything else in the proximity of the battery indicating leakage if it's a non-sealed battery, things of that nature. So we want to do a visual inspection. We may want to ask the customer, has this battery been replaced? If the vehicle has been towed in by a towing service, we want to ask, hey, is there any chance that the towing service put a battery in this vehicle? Of course, you can use your eyes to look at the battery that's in the car. Does it look brand new? What's the date stamp on the battery? If the date stamp on the battery is this year, there's a fair bet that that battery was just replaced, right? So again, looking for basic visual clues as we go through and we look at this stuff, but also remembering to ask the customer, hey, have you replaced the battery? Now you're asking, well, why do we care about any of that? We also need to understand if there's any other symptoms that could be related to a battery electrical related concern. Are there any other weird anomalous behavior? Door locks are cycling, or The wipers are coming on and off randomly, right? We need to ask about if there are any oddball clues that might lead us to believe there's a 12-volt electrical system concern. Now, the other step that gets skipped a lot of the time in terms of battery diagnosis, and also with respect to charging and starting, is a thermal imaging inspection. This takes very little time, but it can help you find smoking gun problems in just a few moments. So as we look at the information here, let's understand. When we're dealing with 12-volt electrical systems, specifically, obviously, the battery starting and charging system, these are responsible for, specifically the cables and the cable ends, are responsible for transmitting or carrying a large amount of current. Not necessarily a large amount of current for a super long period of time, but relative to the rest of the vehicle, yes. That's why we have large gauge wires. Those big gauge wires are not meant to get very hot. They are meant to be pretty close to ambient temperature if all things are normal and working correctly. So the thermal imager is capable of picking off if there are issues with any of this stuff in a very quick moment. And we're going to show you an example of how to pick this kind of stuff off. Generally, if we see an increase in electrical resistance in the circuit, so at the battery cable ends, inside the cable itself, things like that, that's usually going to create heat. If there's increased electrical resistance, that is also going to create a voltage drop. If voltage drop occurs, we can then also experience strange electrical symptoms. It can also cause damage or other problems with the vehicle 12-volt electrical system. We also need to understand that that increased electrical resistance can cause a buildup of heat. So what that's going to look like to you is essentially hot spots. As we go through and we go to perform any testing on the system with our thermal imager, as we look over the battery cable ends, as we look over the battery cables from their starting point to their ending point, as we look at any grounds that we can physically see, especially a ground that would go between the battery negative terminal and the body of the vehicle, as we're looking at that, we want to pay close attention to see what kind of temperature we're seeing there. If we're seeing hot spots or buildup of heat, that is often an indicator that there is, in fact, increased electrical resistance, which is going to suggest there may be a connection problem there, or there could be damage internally to a cable or something of that nature. And again, we're going to show you some examples of this. The other thing we want to keep in mind here as we use the thermal imager is when we think about how the battery works and what its job is and the time when it is under the greatest amount of stress, as well as all of these connections being under the greatest amount of stress, is when you go to crank the engine. So when you go to crank the engine, the initial inrush current that flows to the starter in order to start rotating the engine is the greatest amount of current flow that you're going to see in that circuit at any point in time, at least in a normal system. That being said, if we are to create, let's say, for instance, crank the engine for 10 seconds, 3 consecutive or 4 consecutive or 5 consecutive times, if we do this multiple times in sequence, if there is a suspect or marginal connection, it's going to heat up rather quickly because we are pushing a lot of current through it or attempting to push a lot of current through it. So if you're not sure, let's say you do your battery test and it tests marginal, and you're not sure if that is something related to a connection problem or something of that nature, simply cranking the engine sequentially 3 or 4 times for 10 seconds, and or if the engine actually starts, you could also just crank it and start it, crank it and start it, crank it and start it a handful of times consecutively, and then look for those hot spots with your thermal imager. So here is an example performed with a thermal imager where we did find an issue immediately just by the initial inspection with the thermal imager. So in this particular case, this vehicle had a anomalous set of electrical symptoms with the 12-volt electrical system. So essentially what we had was wipers coming on and off intermittently, some lights were coming on and off intermittently, just a number of really oddball electrical symptoms. When we took out the thermal imager and ran it across, this is the positive battery terminal connection here, what we found was excessive electrical resistance in the connection here at the battery positive terminal post. Because there was excessive electrical resistance in this connection, you can see in the thermal image here, we had over 230 degrees in one of the pictures or spots on the picture here because there was excessive electrical resistance. Now, what was that caused by? The metal inside this positive battery terminal assembly is actually kind of thin and flimsy and not very well made. Metal fatigue on this particular component actually led to essentially damage. The damage caused a poor electrical connection, which essentially created our heat situation or buildup of heat because the vehicle was no longer capable of keeping the battery charged or essentially using the battery as the reservoir of energy or electrical energy. So when current can't get in or out of the battery because of electrical resistance like this, then you're going to see a buildup of heat typically at the point where the resistance is occurring. So in this case, this vehicle had excessive electrical resistance on the positive battery terminal. Once this was remedied, the battery positive terminal was almost perfectly ambient temperature, even under the highest stress situations. In other words, when we were starting the engine or when we turned on all electrical loads. So it's important to understand that. This was another image that illustrates exactly the concept we're trying to get across here. So this is from a friend of mine, Mike Rowe. This vehicle had a charging system concern, and of course, that might show up in a battery test. If we go in and we do a battery test and we find that the battery tests low state of charge and potentially even faulty, the battery may have been damaged as a result of a poor electrical connection because the alternator is not able to keep the battery adequately charged. So as we see here, in this case, this this positive lead that is connected to the alternator is actually blackened and charred. The nut that is on here was not tightened down properly. This alternator was installed by a customer or another shop, so not by the shop that diagnosed it. And if you look here, the nut that was on the positive lead at the alternator is actually 300 degrees Fahrenheit. That is occurring because there is electrical resistance due to a poor connection. So as you can see, that shows up very readily with the thermal imager. So as we walk around with a thermal imager looking for things like this, if we see any component, a battery terminal end, an alternator positive lead, or even the cable, as we run the thermal imager across the expanse of the entire cable from end to end, if we see a massive hotspot in the cable, either at the ends or in the middle or anywhere in between, then we know that there's a problem with the cable itself or the connections. So again, these are the types of things that we're looking for using the thermal imager on a basic inspection. Again, a hugely valuable and important step in your initial inspection if you're dealing with a 12-volt electrical concern. So now, talked about the thermal imager's role in the inspection. Let's talk about how we test batteries. Now, there are a number of different Topdon tools you can use to test batteries, and each one of them has different features, different strengths, different weaknesses, and of course, different user interface, which is going to speak to your preference, right? Oh, nice. We got a good comment here. Thank you. Appreciate that that comment there. Yeah, it's pretty cool when you find the thermal imaging stuff. When you come across the problem, I've actually come across problems that maybe were not even tied to a customer complaint because I've integrated the thermal imager as part of my standard inspection criteria, honestly. When I do an underhood overall visual inspection, I will actually take out the thermal imager and just kind of run it across the engine bay and look for hotspots. because you honestly do find sometimes anomalies and outliers that you're not even looking for. So let's talk about the testers. What we need to understand about testers, and obviously, like I said, Topdon offers a very large variety of different testers, and each one of them has their strengths, their weaknesses, and their user interface preferences. So we have a number of testers that are like the BT Mobile Pro S. So the BT Mobile Pro S is for scan tools. That's what the S is, what I like to refer to as the S in pros is for scan tool. There's also a BT Mobile Pro that is not for scan tools specifically that works similarly, but is actually not the same. It will not work with the scan tool unless you install a separate app. That being said, the BT Mobile Pro is very much a product line that is designed to be PDF reports, digital friendly, that kind of stuff. So it's great for that. However, some people don't like this user interface. Then we have the BT600 and the BT600 Plus. Those are usually considered our commercial service or mainline shop use type of battery testers when the shop prefers the printout style report or the normal user interface that's just on a standalone tool. Now, what you'll find is both tools and both formats can perform the same basic tests. You can do battery tests, you can do cranking tests, you can do charging tests. You can do all of that with both the BT Mobile Pro series as well as the BT600 Plus and BT600 and similar tools. What you find is there is a little bit of a difference as far as how the process works. Now, the other things you're going to notice is when you are using them, you want to be mindful of the same types of things. So I have written essentially a procedure that I use for battery analysis. And this is a great, simple, standardized protocol. You're more than welcome to use this in your shop. You're more than welcome to print this. You're more than welcome to take it, edit it, whatever it is that might help you. But if we're dealing with 12-volt electrical, specifically related to batteries, I always test the battery first before I do anything else other than the pre-scan. I do an initial test on the battery, typically using the BT Mobile series or the BT600 series. Then I'll do a visual inspection and a thermal imaging inspection, going over battery cable ends, battery cables, the battery itself. Sometimes you actually find issues with the battery itself. The battery itself is super hot. Well, there's probably a high internal resistance of the battery, right? Then, after I've done the visual inspection and the thermal imaging inspection, if my initial test of the battery was inconclusive, or perhaps the tester says charge or recharge and retest, which is a result we do see with some frequency. If that was the result we obtained, then we may want to do the retest like we mentioned, where we're going to start the engine a few times consecutively, and then we're going to retest the battery. See if the battery performs the same after stressing it a few times, or if it's worse. If it gets considerably worse, then there's a good chance that the battery is in fact defective. If, however, the battery performs relatively the same, then we may want to simply go recharge the battery using our Tornado 90,000 or our Tornado 120. Once we've recharged the battery, then we may want to do our test over again. If, of course, we find the battery is in a low state of charge during any point of this, typically at the initial testing, if we have a low state of charge, let's say we have, and again, remembering to check the chemistry, right? So if we have a lead acid conventional or an AGM battery, our normal full charge voltage is going to be somewhere between 12.6 to 12.8 volts. You will find it may be a little higher than that or a little lower than that. Some AGM I've seen as high as 13. Some lead acid I've seen 12.7, but typically somewhere in that region for full charge. Most of the time, batteries will not be at perfect 100% charge. They'll be somewhere within 100 to 200 millivolts of that, maybe a little less, depending on the health of the battery, the age of the battery, and whether or not the customer is doing a lot of short trips. Once I know that, If it is a conventional lead acid or an AGM, and I'm much lower, so let's say I have a conventional lead acid or an AGM and I'm at 12 flat or less, now I'm concerned, number one, about testing that battery multiple times to make sure that I get accurate information and also stress the battery to see if we can get it to fail by stressing it. But additionally, we want to make sure we're stopping and having a conversation here that this vehicle may need to have a battery draw test carried out because there is usually going to be a cause associated with that battery sitting in a low state of charge. Now, again, you notice I'm specifying conventional lead acid or AGM. If we have an EFB or enhanced flooded battery, we may see that standard resting voltage much lower than what we do on the EFB, or excuse me, on the AGM or the conventional lead acid. That resting charging or charged voltage on the EFB might actually be 12 flat. I own a vehicle with an EFB, and if you go out there and check the battery at any given point in time, it is not at all uncommon to find that battery resting voltage between 11.8 and 12.2, and it's completely normal. 100% completely normal. So, very important to understand that you need to pay attention to that chemistry right at the onset because that's going to affect your interpretation of the results. That also holds true if we have to go into oscilloscope testing, which we've talked about oscilloscope testing of batteries before, and we're not going to get into that in depth today, but that is important for you to understand that whether we're testing it with the BT600 series or the BT Mobile series or any other Topdon tester, understanding that which chemistry battery we're testing is going to dynamically impact our interpretation of the data. So again, make sure you understand that, because if you don't notice, hey, I'm testing an AGM, and you test it and it's at 11.8, and you think, oh, that's fine, no problem, you're probably wrong. If you're testing an EFB or enhanced flooded battery and it's at 11.8, that may be completely normal. However, if we're at 11.8 volts on an EFB, that may signal that it would be a good idea to do a desulfation charge after fully charging that battery up through the conventional method. And we'll talk about that in just a few moments here. But again, understanding all of this through the battery testing steps is really important. Knowing the chemistry of the battery first is key. Understanding what a normal state of charge is for that battery chemistry is key. And then realizing that after that, if you know it's well below what it should be, making sure we time out, stop, and make sure we notify the customer, or if it's your vehicle, understand that a battery draw test is likely going to need to be carried out after we verify visual inspection, thermal imaging inspection, and then making sure that we charge the battery correctly, and if necessary, perform a desulfation charging as well, which again, we're going to go over here in just a minute, and then retesting afterwards. So again, lots and lots of critical thinking stuff we have to be aware of here as we deal even just with 12-volt batteries. So sometimes you're going to use the quick tester like the BT600 or the BT Mobile. That's not going to be enough, and that's when the Topdon oscilloscope is what's going to be what you need to switch to. Again, we're not going to get into the testing on that tool today because we just don't have enough time, and we could probably do a webinar on that exclusively for the whole time. But we're not going to get into that in depth today. Let's talk about charging batteries. We need to cover this before we wrap up for today. So understanding that when we're going to charge a battery, the chemistry factor of the battery is just as important to understand here as it is to the service part, where we're just testing it, analyzing it, interpreting data. We have to also understand the chemistry part here when we're doing the charging. Now, these battery chargers are prepared specifically to work with a wide variety of different batteries, but you want to understand what the settings are used for. So to that effect, if we are using a lead acid conventional, lithium, or AGM, both the Tornado 120 and the Tornado 90,000 will typically have automatic settings for these. Some models may not have automatic settings for lithium, some do. Do not charge a lithium if you don't have automatic settings available. If you have lithium automatic settings, then you can charge a lithium. Lead acid conventional is going to have a normal lead acid conventional charging setting. AGM is also going to have a charging setting. For lead acid conventional only, there is a repair function that is appropriate specifically for lead acid batteries. It is not appropriate for AGM. It is not appropriate for EFB. You need to understand if you have an EFB or an AGM battery that is having an issue, the way to recover that battery is not the same. We're not going to talk about AGM recovery. AGM recovery, I typically just recharge the battery using the normal AGM mode and then retest the battery. I'm not going to try and do any specialized recovery mode. Now, unless the user manual says you can, don't do that. Always check the user manual. Of course, they do also update the software on these units, in some cases over the course of the product lifespan. So make sure you're reading the user manual to verify whether or not that is called out in your specific tool, if there is a modification that allows you to use any of these settings that normally are not outlined here. If we're dealing with EFB or enhanced flooded batteries, oh, funny. Yeah, I'm not surprised to hear that the battery can have an impact even on a learning procedure. Yeah, that makes a lot of sense, actually. We do see that battery voltage is such a crucial element. Relearns, vehicle performance, any actuators on the vehicle. If those are large electrical loads and the battery is in a weak state of health, you could definitely see when any actuator switches on, you can absolutely see an issue with that. Because, of course, the alternator can only respond to the load so fast. So if a large electrical load were to switch on, like let's say a large clutch drive motor on an automatically shifted manual transmission, that could be a large amount of current at once, and the alternator is only going to be able to respond so fast. You also have to understand that alternator RPM is going to affect the amount of current that the alternator can deliver, and that response is only going to happen so fast. Whereas if an actuator is switched on and a large amount of current demand comes on right away, the alternator is going to try to meet that. But if you have a weak battery, that could definitely cause issues or faults, not only with a learned procedure, but also in performance when driving the vehicle. So good point. Great share. So back to EFBs, we have to understand that if we're going to try and repair an EFB, the first thing we want to do is use the regular lead acid charging mode, not repair, but charging mode. So we're going to do the charging mode with lead acid. Then, once we've charged the battery fully on an EFB, then we're going to do the desulfation procedure. So the desulfation procedure on EFB batteries specifically, we will talk about in just a minute here. I'm just going to look. I think I've got it. I did not put it in here, so that's my apologies. If we're going to do desulfation specifically for the EFB batteries, we need to set the current limit, like I mentioned before, to roughly 20 amps or so. You could probably go a little higher if you want. And then you're going to put the battery charger, the Tornado 120 or Tornado 90, in supply mode. And you're going to set the voltage to 14 to 14 and a half. Again, after we've done the normal conventional lead acid charging mode on the EFB, the battery voltage should come up to about 12.6 when it's fully charged. Once that conventional charging mode is complete, then the desulfation mode that we're going to have to do, and again, this is manual for the EFB battery specifically, the desulfation charge is going to be 14 to 14 and a half volts. We're going to limit the current to roughly 20 amps. You can go a little higher if you want to, but you're going to watch that current output from the charger. It's going to start high in most cases, and it's going to stay pretty high for a period of time. Now, as it desulfates the electrolyte, it's going to take time to work through this process. It can take up to 5 hours for this to happen. As it desulfates the battery electrolyte, it's going to taper the current off over time automatically because you're using supply mode. So when you have supply mode set to hold a stable voltage, it's basically going to supply that voltage to the battery and push as much current as the battery will accept until the desulfation is starting to complete. Eventually, the current is going to fall off until it gets down to around an amp or less. Once you see it start to fall below about an amp and a half or less, you know that the desulfation charging process has been completed and the battery should be successfully repaired. Again, this applies to EFB specifically. You can look up desulfation process for conventional lead acid, but there is no need because the repair function on your Tornado 90 or 120 can handle conventional lead acid batteries. It's the EFB batteries that you need to do manually. So again, EFB batteries, manual desulfation. Charge them using regular lead acid charging mode, then use stable voltage supply mode set to a 20-ish or 30-ish amp limit and 14 to 14 and a half voltage. Then monitor the current output from the charger until it tapers off to about an amp and a half to an amp. Once it reaches that level, you can turn off the charger and the desulfation should be complete. Again, understanding if we're doing any desulfation, we need to do it in a well-ventilated area. Okay, so now let's talk about one more thing before we wrap up our webinar for today. We need to understand many modern vehicles may require relearns, coating, or adaptations for the battery when the battery gets replaced. If you have a vehicle, whether it's your own personal vehicle, or you work at a parts store, or you are a technician working on cars professionally, if you have any vehicle history or customer reported symptoms that the battery has been replaced multiple times in the recent past, there is a good chance that either A, there is a fundamental problem with the vehicle's 12-volt electrical system, or B, this process has not been carried out properly when the battery has been replaced. So if we're trying to identify a vehicle that may require battery coating or relearns, the first place I like to start is looking at the battery positive and negative cable ends and looking for a battery current monitor sensor. Typically what you're going to see, this is just a stock image from Google, the battery current sensors are usually going to be mounted right to the positive or the negative battery terminal. If you see a battery current monitoring sensor like this, this also affects how we charge the battery if we're charging the battery in the vehicle, or if we are using our charger in stable voltage supply mode, specifically for programming or diagnosis. If the vehicle has one of these battery current sensors that is set up like this, where it's on the cable end of the battery, then we need to make sure that we connect the battery charger. It's typically going to be on the negative cable end. So this unit here, you see this battery current sensor is usually going to be on the negative battery cable end. We need to make sure we take our cable for our charger. The negative cable has to be placed on, typically there's going to be a remote negative jumper port, either on the firewall of the vehicle or somewhere under the hood or on the engine block. Again, the negative battery cable, and we're going to look for a negative jump post. We need to make sure the charger is attached there. And the reason for that being is this sensor needs to be able to measure and recognize any charging current that is being pushed by the battery charger. If you clamp your battery charger negative terminal right on the battery negative, it's going to bypass the sensor, and the sensor is not going to measure the change in battery charge state. So again, important to recognize that when you are charging a battery, but also important to notice if you see a sensor like this, it means there's a good chance that that charging system is adaptive. The other thing that you can look for is if the vehicle has any start-stop technology or hybrid-related technology, there's a very good chance that a relearn, a coating, or something similar will need to be carried out after a battery replacement has been done. So again, it's usually going to be something on the battery cable end. Sometimes you may have a battery current monitoring sensor that will look like an amp clamp around the battery cable. So if you have an amp clamp looking apparatus around the battery cable, there's a good chance that that is also a battery current monitoring sensor. So you want to watch for those as well. The other thing you want to do is make sure that you're reading the service information about your specific vehicle so you can understand what the requirements are with respect to battery replacement. There may be relearns that'll be required after you remove the battery, relearning window limit position, sunroof, that kind of stuff, but also potentially coding or data erasure or something of that nature will need to be carried out if a battery is replaced. So again, understanding what you're looking for so you know what the requirements are likely going to be when you do any battery service is very important. So as we talk about battery relearns and coding, you're going to need a scan tool for this. Scan tool servicing is something that most of the Topdon tools are capable of. You always want to visit topdon.com, click on the support tab, and go to the vehicle coverage map to verify if a given tool will cover this function. It's not always going to cover this function on every car. Obviously, we do our very best to get comprehensive coverage on as many as we can. But again, be aware, you need to check the coverage map if you want to verify if this is going to be covered for your specific vehicle. There is going to be a maintenance menu shortcut in most cases that will take you to the procedure for battery relearns or coding. However, I've definitely found that that is not always the case. Of course, the engineering team does their very best to try and ensure that the battery management system shortcut on the scan tool maintenance menu will take you there quickly and efficiently, but there is always the possibility that it will not. If it does not, or if the maintenance menu does not seem to be working, you need to find out which module on the vehicle is in charge of current management or power moding. Essentially, what this boils down to is the module that is in charge of making decisions on switching electrical loads on or off. Commonly or frequently, this may be a module like a smart fuse block, a body control module, or potentially the engine control module. So typically speaking, those relearn procedures or coding procedures are going to be carried out through one of those modules. Some vehicles may also have a battery current sensor that can actually be interacted with directly. Or if you look at the wiring diagram for the battery current sensor, frequently battery current sensors will be LIN bus. If you follow the LIN bus wire from the battery current sensor to another module, whichever module the battery current sensor is connected to is very likely to be the module that is going to house or have the procedure for the relearn or the coding inside it. So for instance, on Volkswagen Audi, the battery current monitoring sensor is wired to the gateway in most cases. So the battery relearn or coding procedure is going to be carried out oftentimes either through the gateway itself or through a software address that lives within the gateway. So again, following the wiring of the battery current sensor to whatever module it's connected to will also give you insight as to which module may have the relearn or coding procedure inside it. So hopefully that clarifies that and makes it a little easier. Here's just an example of where you would find a battery management system under the maintenance. BMS is typically what you're going to find that labeled, whether we're talking about the Topdon Phoenix series or we're talking about the TopScan Pad or the TopScan Pro or any of the other Topdon apps or tools. Again, it's almost always going to be labeled BMS for Battery Management System. And again, that's Baker Mary Samuel. So BMS. So if you look for BMS, that's going to be the procedure hotkey in the maintenance functions menu. So again, that's where you're going to look for this procedure. So glad that you folks have had the time to just take a little bit of time to do some training with us here today. We really appreciate you taking the time to attend the webinar. Obviously, if you were not able to attend live, that's not a problem. We always record these webinars and we put them in the live tab on the Topdon official YouTube channel. So if you are looking for additional training from us, always check the live tab on the Topdon YouTube channel. We always appreciate anyone taking the time to watch these trainings. We really want to try and deliver training that will help you fix your cars better. Also, help you use your Topdon tools more effectively. All of this information is the type of information that it takes to service cars professionally and be more successful. Even if we are a DIY working on our own cars, this is the kind of subject matter knowledge that you're going to need in order to be able to be the most successful. So if you have the opportunity to take the time and slow down and watch these webinars, please do, whether it's live or on the recording. If you have any thoughts or recommendations for other webinars you would like to see us do in the future, by all means, please don't hesitate to hit us up on social media and let us know. We are always excited to interact with our end users, and we appreciate your feedback. And our goal is always to try and make things easier for you, both in using our tools as well as bringing new features and functions to the tools themselves. So, as always, I'm Hawken with Topdon, and we look forward to seeing you on the next webinar. Thanks again for coming.